Let us solve some inequalities. So let us consider this one absolute value 2x minus 9 minus 3 less than 2. So the first thing that we need to do here is to isolate the absolute value expression. We have here absolute value of 2x minus 9. We added a 3 to both sides. We will get here 2 plus a 3, which is equal to 5. Now, since this is less than, it is like you are looking for a number whose distance from the original is less than 5. So this number 2x minus 9 must be between negative 5 and positive 5. So it must be between 5 and negative 5. Now we can solve this compound inequality. So here we can add 9 to all sides here to get off the minus 9 in the middle, and we will get here 4 less than 2x and then less than 14, and finally to find the x we divided all sides by 2 divided by 2 divided by 2 divided by 2, and we will get a 2 less than x less than 7. So therefore our solution set here, solution set which is usually denoted by SS, is equal to the interval notation of this one. It is the open interval 2, 7. It is all real numbers between 2 and 7. Now what if we are given a less than or equal to instead of strictly less than? What will happen to our solution? So actually our solution will be to this previous inequality. If you have less than or equal to, so all we need to do here is to put equal signs. So you have less than or equal, and then less than or equal, less than or equal, less than or equal, less than or equal, less than or equals, less than or equal, and our solution set will be, instead of open interval 2, 7, it will be a closed interval 2, 7. Let's consider these inequalities. We have here absolute value of 3x minus 1 all over 2 greater than or equal to 4. So what can we say about this number 3x minus 1 all over 2? Since it is absolute value is greater than or equal to 4, then that means that this number 3x minus 1 over 2 could be less than or equal to negative 4, because if you have a number that is less than or equal to negative 4, its absolute value will be greater than or equal to 4. Or if it is a positive number, then we are sure that 3x minus 1 all over 2 must be greater than or equal to 4. Now we solve these two inequalities separately. So we have here for the first inequality, we multiply to both sides. Since that is a positive number, it will not change the direction of the inequality. So you will have here less than or equal to negative 8, and then added 1 to both sides. You will get here negative 7, and finally we divided both sides by 3. It is a positive number. It will not change the direction of the inequality. So we will get here x less than or equal to negative 7 over 3. Now for the second inequality, again we multiply to both sides, and we will get 3x minus 1 greater than or equal to 8, and 1 to both sides of the equation. We will get a 3x greater than or equal to 9 and divided both sides by 3. So again, this is a positive number. It will not change the direction of the inequality sample. So we have here x greater than or equal to 3. So our solution set will be either our x is less than or equal to negative 7 over 3. So interval notation, so that is negative infinity to negative 7 over 3, or so in this case we have equal signs. We need to include the endpoint, or so this is union. So our x is greater than or equal to 3. So in the interval notation, so that is 3 including 3, so that the square bracket comma infinity. Next problem, so let's consider this inequality here. Again, the first thing that we need to do is to write the left hand side as absolute value of something. So we need to get off this negative 7 here. So we can do that by multiplying negative 7 both sides of the inequality. So if we multiply both sides of the inequality, you will get the absolute value of 5 minus 3x, and then negative 7 times negative 2 is 14. But since we multiplied a negative number, we need to change the direction of the inequality. So don't forget to change the direction of the inequality here, because in this case we multiply a negative number to both sides of the inequality. So now it is already in our desired from absolute value of something less than 14. So when we remove the absolute value, so what are the number 5 minus 3x, whose distance from the original is less than 14. So distance from 0 is less than 14. Then those are the numbers 5 minus 3x, which are between 14 and negative 14. This is the equivalent compound inequality without absolute value. Now can solve this. Next, we get off the positive 5 in the middle by adding a negative 5 to all sides of this inequality. You have here plus negative 5 plus negative 5 plus negative 5, and this will give us negative 19 less than negative 3x, and then less than, you have here positive 9. Now to find the x, we divided all the sides by negative 3. So we have here negative 19 divided by negative 3, negative 3x over negative 3, and then 9 over negative 3. But since this is a negative number, this inequality sample will change direction from less than to greater than. So therefore this becomes greater than, and then greater than, and negative of negative, it is a positive. So this is 19 over 3 greater than x than negative 3. But of course we can write this down as x greater than negative 3. If we read this from right to left, this means it is in negative 3 less than x, and then less than 19 over 3. So this less than 19 over 3. Therefore our solution set in the open interval negative 3, 19 over 3. Moving to our last two inequalities here. For this first one, again the first step is to move the foil to the right hand side of the inequality. So here we will get absolute value for minus 7x less than 2 minus 4. That is the negative 2. That is the same thing as subtracting 4 from both sides of the inequality. Now, as you can see from here, we have absolute value of something less than negative 2. But what can we say about absolute value of a number? Absolute value of number is always greater than or equal to 0. So do you think it is possible to find a number whose absolute value is negative? Of course not, because again, absolute value of a number is always greater than or equal to 0. So therefore, our conclusion here is that this inequality has no solutions, or we write our solution set as empty set, using this one set containing no solution, or we use also this grouping sample to denote an empty set for the second inequality. So we have here again same things. We move to the right hand side of the inequality, and we will get absolute value for minus 7x greater than negative 2. So the difference here is only the inequality. This is less than and this is greater than, but we know that this left hand side is always greater than or equal to 0. So if it is always greater than or equal to 0, then it is always true that its value is greater than negative 2 for all x. So therefore, all real numbers are solutions. So all real numbers here, all the real number are solutions. X can be any real numbers. We write down our solution set, which is equal to set of all the real numbers, or you may write this in interval notation, negative infinity to positive infinity.